Welcome to Ask and Learn.
So in this question, we are trying to estimate the static electricity charge that will happen if you walk across an insulated floor. So let's assume, we're assuming again, that the sole of a person's shoes has an area of 1.5, 150 centimeters square. A little bit large, but okay. And then when the foot is lifted from the ground, your shoe sole will acquire an extra charge Q from the floor. Let's assume that the sole is a conducting plane. This is not accurate. Most soles are not conducting, but we're trying to model it. But your foot is. So here we're just modeling it as a conducting surface with Q uniformly distributed. And let's see if we have assumed the dielectric strength is 3 times 10 to the 6 Newton per coulomb. The maximum possible charge. Okay, so how do we solve this one? We already know what E is. E is a dielectric, means just an electric field. And from Gauss's law, we know it's density over epsilon naught. Charge density is Q of A. So from this, and we know A, we know epsilon naught, just air. We can figure out what Q is. Q is E times A times epsilon. So E is 3 times 10 to the 6 Newton per coulomb. Now is 8.85 times 10 to the negative 12 Newton per meter. Finally, we have the area of the shoe, but we have to put it in SI unit. So this area together, 4 times 10 to the negative 7 coulomb. So the maximum amount of charge that you can get rubbing the floor. Then we say that, okay, we're modeling a person as an isolated conducting sphere of radius 1 meter. Estimate a person's capacitance. Okay, if you have done question, I believe 70. If you have done question 70, you can just say it's around 100 picofarad, because that question introduced a shortcut, which is quite interesting. If you did not do that question, it's just use a normal formula for capacitance. By epsilon r. In this case, we have r around meter. So we have 4 times 8.85 times 10 to the negative 12 farad per meter. Then we have the radius to be 1 meter. So finally, this is going to 1.11 times 10 to the negative 10 farad, which is roughly just 10 to the negative 10 farad. All right, so that is for part. And finally, for part C, the question asks, okay, estimate the maximum potential difference between the shoe and the floor. All right, I mean, that's just V equals Q over C. We know what Q is. We calculated from part A, calculated what C is from part B. So it's 4 times 10 to the negative 7 coulomb over 1 times 10 to the negative 10 farad, which is around 4 voltage. So there's actually a huge between your shoe and the floor.